Hello students, how are you? Today I have a topic for class 9 and 10. First of all, let us understand real numbers. Real numbers. Students, this real numbers is denoted by capital R, bold, capital bold R. If you see, that is real numbers. Now you might be thinking, what are real numbers? All natural numbers are real numbers. All natural numbers are real numbers. Remember, natural number means I think it's 1, 2, 3 and dot 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 so on. All are real numbers. Okay, all whole numbers are also real numbers. That means 0 is also included in real numbers. Then all the integers are also real numbers. Z is integers. So it is natural numbers which are positive, and 0 and -1 and -2 and -2 and -3 and -4 and so on up to infinity. So Z denotes integers. Integers are also real numbers. Then there is another bigger set you can think of. This is Q. Q is rational numbers. Rational numbers. What are those rational numbers? Rational numbers, if you want to define, first of all you will tell that all integers are rational numbers, because rational numbers can be expressed in the form P by Q, where Q is not equal to 0. This was the definition which you had learned earlier, isn't it? Okay, Q. Now what kind of numbers are rational numbers? This is what I was talking about just now. All these numbers are rational numbers plus terminating decimals. Terminating decimals, example is 1.25, 3.625 and all these are rational numbers. And if it is non-terminating, it has to be recurring, and reoccurring is recurring. R-E-C-C-U-R-I-N-G, recurring. For example, 0.3333. So we used to write 3 bar, isn't it? 0.3 bar is 0.3333, continuously 3 comes, or 0.474747 comes. If you think of 8 by 3, 8 by 3 is 2.66666 continuously. These are recurring numbers, and they are also your real numbers. Exactly. Some students, they ask me, sir, whatever I know, all are real, isn't it? So, but you were saying that real means rational and irrational. This is rational. All are real numbers. These real numbers are one part as such. The another part is irrational numbers. NOS, okay, numbers. Irrational numbers denoted by capital I. Let us denote it by capital I. My students ask me, sir, how do we identify these irrational numbers? I tell them only one thing. If you want to identify irrational numbers, just write root 2, root 3, root 5, root 7, root 6 also, okay, and so on. But why are these numbers irrational numbers? These numbers are irrational numbers because, I'm just joking with you, okay, because they are non-terminating and non-recurring. Non-terminating and non-recurring. You might be you might be taken aback with one particular incident which has happened recently in I think it's in USA. One of the prisoner, he asked for mathematics book for some time, and after that he gave a theory on irrational numbers. Please Google, okay, find out the prisoner's name, and it has been established. Scientists have discovered that he has got a new thesis. Very good, isn't it? So learning has no age, You as a student also can make a difference in the society by giving your particular opinion on different types of numbers. Okay, there is a possibility for 0 by 0. 0 by 0 is, I don't know, undefined, we say. So you can always think of, there are a lot of gray areas in mathematics you can always work on. Okay, when I'm talking about real numbers, I had this in my mind. It is undetermined, yet to be determined. So we don't know what it is. So these are irrational numbers because they are non-terminating, non-recurring. If you want to see pi, the value of pi is 3.1416, and after that different number comes, so that is also irrational numbers. The value of e is exponential e, that is related with log base e we write. You must have seen the function e to the power x also. It is 2.787765, whatever comes, I don't know after this. So this is also what? Irrational number. So these numbers, whether it is rational or irrational, together they are real numbers. What are they? They are real numbers. Why they are real numbers? Because all the numbers you know are real numbers. Next is, all these numbers, whether it is real or whether it is rational or irrational, they can be plotted in a real line. This is called real line. Okay, it goes to infinity, minus infinity to infinity. It has 0 in between, and say it is 1, it is 2. All these numbers, whatever we have written, can be, like, kept in this real line. It is continuously moving both sides, indefinite line. So how do we identify 3.14 here? 3.14, if I go a bit further, say I have to go here, this is 3 and this is 4, 3.14, this is pi here, 3.14 somewhere. Okay, 2.77 here, it is e. Okay, so you can identify all the numbers in the real line. Real line consists of rationals also and irrationals also. Euclid's division lemma. This is a new term, lemma. Lemma is a proven statement. This is used to prove other statements also. A line can be produced indefinitely both sides. It's a lemma. The right angle is equal to 90 degree. That is a fact. That is a lemma. Circle has no corners. That is also a lemma. Okay, we can use 2 is less than 4. Fact. That is a lemma. So, so many lemmas, if we use in steps, that becomes algorithm. Lemmas together make algorithm. So Euclid, he is also a renowned scientist around 400 BC. Okay, so what he did is, Euclid is also, he's a father of geometry. Now this particular topic we start with class 10 syllabus, Euclid division lemma. Think of these numbers. Say if I divide 7 with 2, 2 into 3, 6, remainder is 1. How do I start? I started with 2 and 7. Let us denote 2 and 7 as given numbers, given. And these are A and B. A is always greater than B. This is B. Okay. Given two positive numbers, given two positive numbers, A and B. So my A and B is 7 and 2. You know this, like dividend, divisor, quotient, remainder. Here we have Euclid division lemma also. Division they are using, so I am showing you the division. Given two positive numbers A and B. Now because of this A and B, we have unique, this is Q, quotient, and this is R, remainder. Okay, given two positive numbers A and B, this sign is there exist. Okay, unique integers Q and R, okay, Q and R, Q is 3, R is 1, satisfying the condition A equals to BQ plus R, where you know that if your 2 is the divisor is 2, then remainder cannot be equal to 2, it has to be less than 2, where so this is B is your 2, then R will be less than 2, it can be 0 also, where 0 is less than equal to remainder is less than B. Okay, so it has to be, remainder has to be less always. So this is Euclid division lemma. Now using this Euclid division lemma, we can form algorithm. Algorithm is a series of steps used, okay, lemma, series of lemmas used, we make algorithm. So let us go to question number 1. Please copy this properly by like keeping a pause and copy it properly, so that we move on to the first of the important questions, that is use Euclid division algorithm to find HCF of 1, 2, 5, 0 and 15. Fine. So this is the first of the kind, using Euclid division algorithm, find the HCF of. How do we proceed with this? Okay. So what we do is simple. एक बार breathing कर लो, आराम से question को समझिए. What they are saying, you just have to understand. Use Euclid division algorithm to find HCF. We have to find HCF of this two. Okay. So how to find HCF? 1, 2, 5, 0 and 15. इन दोनों का HCF निकालना. We have to find the HCF of 15 and 1, 2, 5, 0. So we can do this using prime factorization method also, but Euclid division lemma. So let us identify this as A and this as B. Okay. So first of all, let us divide 15 and 1, 2, 5, 0. 15, 6, 90, 15, 7 is 100, 15, 8 is 1, 2, 0, 50. 15, 3 is 45. 5 is remaining. Isn't it? So what we can write is 1, 2, 5, 0, okay, equals to 15 into 83 plus 5. Now you know this is C and this is D. Now we have to perform here also. So write 15 equals to 5 into 3 plus 0. The moment we get 0, we can directly say that this is the HCF. HCF equals to 5. We can take several examples, okay, in this way. One more example I can show you. HCF is 5, okay. One more example. Let's take two numbers. Example. Let us take 210 and one number, say 15. 16, okay, 16 and 210. So what we can do is, I'm just giving you one more example to understand this concept, how to write algorithm. But before we write this algorithm, since we can write using Euclid's lemma, what is the lemma? A equals to B, Q plus R, and A and B is this, and we are using this. HCF is 50. Okay, this answer is complete. Let us check with this 210 and 16. So how do we proceed? Just try 16 and 210. 16 1, 16 5 0, 16 3, 48. So here we write using Euclid's lemma. 210 a equals to bq plus r, a equals to bq plus r. Okay, so 210 equals to 16 into 13 plus how much? 2. Now we have 2, 16 and 2. 16 equals to 2 into 8. The moment we do so, we get 0. When the remainder is 0, directly say that 2 is the HCF. Fine? 2 is the HCF. That any positive odd integer is of the form 4q plus 1 or 4q plus 3 for some integer q, for some integer q. Okay, deep breath, isn't it? So we are in question number 2. Remember students, these are first two very important questions of Euclid. What is the chapter? Real numbers. Yes. So that any positive odd integer. So first of all, let us start with, it is given that a equals to 4q plus 1 using Euclid division lemma. A equals to bq plus r, 0 is less than equal to r less than b. Always write this. You get 1 mark at least. 1 mark तो मिल जाएगा आपको अगर ये लिखोगे तो. मैथ्स किसी को पसंद नहीं है, लेकिन प्रैक्टिस करोगे ना, एक बार वो आपका हो गया मैथमेटिक्स, तो फिर जिंदगी भर यू विल अर्न रेस्पेक्ट. आई एम टॉकिंग अबाउट. ओके, 0 is less than equal to r is less than b. अगर if I compare this with this one, a equals to bq plus r, ये भी तो a है, some positive integer है ये 4q plus 1. So b का value they have given, b equals to 4. If b का value 4 है, b का value is 4, possible remainders क्या है? Possible remainders हो जाएगा less than 4 from 0. 0, 1, 2, 3. Is it okay? Now if possible remainders are 0, 1, 2, 3, the positive integers are a equals to 4q plus 0, एक हो सकता है, a equals to 4q plus 1 हो सकता है, a equals to 4q plus 2 हो सकता है, a equals to 4q plus 3 हो सकता है. There are 4 possibilities. Now so that any positive odd integer is of the form 4q plus 1, 4q. Any positive, I have written positive integers. There are 4 different types. When they are saying odd, 4 is even, so this is even. Even plus even is even. This is even. Even plus odd, this is odd. Even plus even, it is even. Even plus odd, it is odd. Now consider odd positive integers. Implies 4q plus 1 and a equals to 4q plus 3. So here the question is completed here. Q is some integer. A equals to bq plus r, identify b as 4. After identifying b as 4, get the remainders 0, 1, 2 and 3 from Euclid division lemma. After getting the remainders, write all possible positive integers का expression. From there, identify only the odd ones. Odd one है तुम्हारा 1 remainder and 3 remainders. So therefore we consider only the positive integers as odd positive integers as 4q plus 1 and 4q plus 3. 616 members. Question number 3. An army contingent, CONTIN Gent of 616 members is to march behind a band of, that is army band of 32 members. They are giving this question in a parade. Okay. The two groups are to march in the same number of columns. They march in same columns. Okay. They march in same number of columns. What is the maximum number of columns? Find maximum number of columns. This is the third most important question, application based, okay, from real numbers, in which they march. Now what am I going to do is take a deep breath, followed by an army contingent of 616 members. Now think of, I'm making contingent of 616 members, okay. Now this line denotes contingent, okay. These are contingent, and these are bands. The round ones are band. This is band. I'm just showing you band, okay, and this is contingent. Now what am I doing is, first of all, these army bands will be in front, okay, bands will be there, and they will be 32 in number, and followed by these are contingent. There will be so many, okay. So how many you can make like this? There are so many contingent, 616. So they all, this is front, and they all are like in a parade, okay. So they have to be in equal number of columns. You know, this way, if we make a line, this is columns, column 1, column 2, line, columns, okay. So how many columns, what is the maximum number of columns that this army band and contingent fit together in the line, okay, and no one is kept extra. So in that, what we do is, we use Euclid's division algorithm to find HCF. HCF of what? HCF of these two numbers, 616 and 32. 616 and 32. If we find the HCF, students, what happens is, HCF will give maximum number of columns, and after we get the HCF, I can guarantee you that how many band people will be there in each column, how many contingent people will be there in each columns, and how many columns will be there. So if you have a slightest of mathematics knowledge in you, you can easily find out, instead of getting confused, you know, like 616 plus 32, and all the officers will get confused without knowing like how many lines, what not. One simple HCF is going to help you to find the solution for this particular problem for a parade, okay. So what is the HCF of 616 and 32? Please find 616 equals to 32 into how many? 32 into 20 is 32 into 20 is 640, so it is 19. 640, if I reduce 32, then 608, 8 plus 8 it is coming. So I write 32 equals to 8 into 4 plus 0. What I have done, see, A equals to BQ plus R. Now what are those numbers? 32 and 8, write at 32. 8 will multiply 4 times to get 32, remainder comes 0. 8 is the HCF. HCF equals to 8, which is maximum number of columns. Now you know, students, we will have 1 2 3 4 5 6, and say this is 7 and this is 8. 8 into 4. So band people will divide into 8 columns. Okay, so I'll write all the answers properly. Band makes 8 columns, okay, with 4 members in each column. Okay, and this 616 contingent will follow. Okay, if I divide 616 by 8, somewhere around 77. Okay, 77 plus 4, total 81 people will be there in each column. Okay, and this 77 contingent will be in each columns, plus 4. This is 4 band members, 77 contingent, total will be 81 in each columns. Okay, so here we go with the answer, that this particular question, Euclid division lemma, when we find the HCF, we get 8. What is the maximum number of columns? Maximum number of columns is 8, and in those 8 columns the question can be asked more than what is given. They may ask you how many contingent members will be there in each group. So easy, isn't it? The number of contingent members in each group is 7. In each column is 77. How many band members in each column? 4. Total 81. How many columns? 8 columns, because 8 is the HCF. Fine, students. Find HCF of 96 and 404 using prime factorization method. So this is question number 4, very important. Using prime factorization method, find the HCF of, also find LCM, also find LCM using the relation LCM into HCF equals to A into B. Remember, A into B are the two numbers A and B. So LCM into HCF is product of two numbers. First of all, let us find 96. 96. So you can perform the prime factors of 96 to 48 to how much is 24, then 2 12 to 6 to 3 1 2 3 4 5. It is 2 to the power 5. Hope I am correct. So 404. Let us write 404 to 202 to 101, and 101, I doubt we have any factors of 101. 101, 13,791, 17,602. So it is 2 square into 101, I guess. Okay, 101 I'm not thinking of. Even if we get, this will be the prime numbers maybe. So LCM, sorry, HCF of 96 and 404. 2 square is 4. Here also 2 square is there. HCF is 2 square, that is 4. We got the HCF of these two numbers as, because like you can write this number as 2 into 2 into 2 into 2 into 2 5 times into 3, and this also can be written as 2 into 2. So let's make pair 2 2. If the numbers like prime numbers occur in both the factors, that is taken as HCF. Okay, and if I want to take the LCM, then let's take the 2 to the power 5 into 3 to the power 1 and 101. That is the LCM. but we are not supposed to do this way. We have been asked LCM into HCF equals to A into B. So that also it is possible, very much possible, easy. How to solve? See, what we can do is, for LCM we can write LCM into HCF. So LCM into HCF is 4, and your A is your 96, B is 404. A is your 96, B is 404. So what is the LCM? 96 into 404 divided by 4. So if I divide, it is 24. So LCM is your 24 into 404. And you know, the calculation is also very easy. 400 into 24, 24 4s are 96, 9600 and 24 4s are 96. So 9696, I guess. Okay, if my multiplication is wrong, please excuse, but I am doing it like what I did is 24 into 400, 24 4s are 9600, 24 into 4, 96, so 9696 is the LCM. HCF is 4. So there is also a relation, LCM into HCF is A into B, that is the product of two numbers. We move on to question number 5. But remember, there is a fundamental theorem of arithmetic also. We call this as fundamental theorem, FTA. FTA is not that Embrigaga FTA, it is fundamental theorem of arithmetic, which deals with this prime factorization method only. Every composite number, this is a composite number, this is a composite number, every composite number can be expressed as the product of its primes. So see, this 96 is a composite number. What is a composite number? Composite number is the one which have more than two factors. Okay, the smallest composite number is 4, okay, which has more than two factors. That is a composite number. Remember, one and itself, except that also there has to be one more factor, so it is a composite number. So every composite number can be expressed as the product of primes, and this factorization is unique. It is unique apart from the order in which the prime factor occurs. So see the book for fundamental theorem of arithmetic regarding these composite numbers. Composite numbers can be expressed, okay, as product of primes uniquely. Only this much if you remember, that is fundamental theorem of arithmetic. Very soon we have reached question number 5. See, and question number 5 says, check whether whether 6 to the power n or 4 to the power n. So let us take any of this. Okay, I will prove 6 to the power n, you will prove 4 to the power n can end with digit 0, with digit 0 for some n, for some integer, for some n belonging to natural numbers. Okay, for some integer n, or let us take n as not the integers, let us take n as natural numbers only. Okay, now you know there is a theorem also. The theorem says if a number is supposed to end with digit 0, remember whatever I said, if a number with its factors is supposed to end with a digit 0, then it must have in its factors 2 and 5. Okay, it must have 2 and 5 both in its factors. So answer, when we write the answer, so what we can write is for a number to end with 0, for a number to end with digit 0, it must have factors of both factors. What it must have prime factors both 2 and 5. Here 6 to the power n can be written as 2 to the power n into 3 to the power n, has 2 as its factors but not 5. Understood? It has 2 to some power n, so it has 2 as its factor, but there is no 5 in it. So for a number to end with 0, it should have 2 also and 5 also in its prime factors. That fundamental theorem of arithmetic. This is a composite number. When we express this composite number as product of its primes, then it must have 2 and 5 both in its factors. But this 6 to the power n have 2 and 3 but not 5. So it doesn't have 5. So 6 to the power n will never end with digit 0. Understood? 6 to the power n will never end with digit 0 because it does not have 5 as its factor. Okay, this much. Prove that root 2 is irrational. Question number 6. Prove root 2 is irrational. Okay, now to prove this root 2 is irrational, what we will do is we will take contradiction method. Contradiction method is like, see, the students who are listening to me, all of you are smaller to me, isn't it? Now if I have to prove I am elder to you, then what I will do is I'll use the contradiction as, let us think that I am younger to you starting. Then I will say that I had seen 1983 World Cup, and knowing that I have seen 1983 World Cup and you were not born that time, that means my assumption is wrong. So what happens is, that means my assumption is wrong means I am younger to is wrong. So what is proved? I am elder to you. So similarly, this contradiction method is, let us take just the reverse of what is to be proved. Prove root 2 is irrational. So what we write is, in answer we write, see, very important, okay, let root 2 be rational. When root 2 is rational, we can express a rational number in the fraction form. P and Q are prime numbers. Okay, just write very simple, P and Q are primes. So root 2 is P by Q, squaring both sides of this equation 1. So I get this as 2, this is P square by Q square. In fact, if I write it properly, I can always write this Q square here, Q square, P square by 2, P square by 2. Okay. A theorem comes which says that if a square of a number is divisible by 2, if P square is divisible by 2, implies the number should also, that is P should also be divisible by 2. That's a theorem. So 36 is divisible by 6, then 6 is also divisible by 6. Okay, so implies P is divisible by 2. If square of a number is divisible by 2, then the number is also divisible by 2. So q square is a result because p square is divided by 2, implies p is divisible by 2. Say if p is a number which is divisible by 2, then don't you think that p can be 10? Because 2 into 5, 10. 10 is divisible by 2. P can be 16. P will be an even number which will be divisible by 2. And if I multiply some number with 2, I get that p. So that some number, let some factor r, okay, is such that 2 times r is p. When we multiply 2 times r, what is r? R belongs to natural numbers, okay? R belongs to natural numbers. So 2r equals to p. So if I substitute this in equation 1, substitute in 1, so what I am writing is root 2 equals to p. P is 2r by q. Or if I square, or squaring both sides, if I write, then this will be 2 4r square by q square, isn't it? 4r square by q square. So r square, 2 1s are 2, 2 2s are 4, so 2r square by q square equals to 1. Or we can even write q square equals to 2r square. Q square equals to 2r square. I want to go back to my, because if I write it down, you cannot see. So I am writing it here. So I just need 1 or 2 more steps to prove. So q square equals to 2r square. Q square by 2 equals to r square, implies, from where I am getting? From here, see? From here I am getting q square by 2 is r square. When q square is divisible by 2, when q square is divisible by 2, implies q is divisible by 2. Raise your eyebrows. You know why? Because I have proved 2 things. I am marking with red. The first one is p is divisible by 2, and the second one is q is divisible by 2, and I am making it asterisk here. This is one asterisk, this is second asterisk. You have to get these 2 terms there. And moreover, p and q are prime numbers. Prime numbers cannot have a common factor. 2 different prime numbers cannot have a common factor. That is why contradiction. P and Q are primes and divisible by 2. P and Q are primes and divisible by 2, which is not possible. So what we were writing is P and Q are prime numbers and it is divisible by 2, which is not possible. So what is possible? Our assumption is wrong. Therefore, what do we say? Therefore, root 2 is irrational. Therefore, root 2 is irrational. Why it is irrational? Because root 2 is irrational because we have proved our assumption wrong. That is why we are saying that root 2 is irrational. So here we go with question number 6. It says express rational in decimal form without long division divide nahi karna hai. So what we have to do is, without dividing, we have to express this 17 by 8 in terms of fractions or decimals, sorry. So what we do is, let us write 17 ka 17 only. 8 can be written as 2 cube, 2 into 2 into 2. 8 can be written as 2, 4, 2, 2. So 2 into 2 into 2. So what you do is, this is equals to 17. You make whatever is the value of 2 to the power, same value of 5 to the power also you have to bring. So 2 to the power 3 into 5 to the power 3 into 5 to the power 3. Multiply numerator and denominator. So what happens is, 2 into 5, 10 to the power 3. And this is 125 into 17. 125 into 17. So what we do is, let us multiply 125 and 17. 125, 17. 35, 5, 3, 7, 2, 14, 3, 17. 1, 3, 1, 3, 4, 75. And 125. So it is 5, 2, 7, 1725. 1725 divided by 1000. 1, 2, 3. 1, 2, 3. So answer is 1.725. So what is the answer? 1.725. So let us write the answer properly. It is 1.725. So what we do is, we import that many powers of prime 5, whatever is the power of 2. Remember, here also 6 by 15. First of all, write 6 as 6. 15 is 3 into 5. Now you have factors other than 2 and 5. So what we do is, let us remove 3. 3 2 just 6 if it is possible. So I get 2 by 5. 2 by 5 is nothing but 2 divided by 2 into 5. I have added 2, multiplied 2. So this becomes 4 by 10. Okay. 4 by 10 is nothing but 0.4. This is the decimal form of 6 by 15 if we express without what? Division. Yes. 35 by 50. Let us write 35 by 50. I make it 100 into 2 into 2. So it is 70 by 100. The answer is, if one decimal comes, 0.7. So in this way, students, every rational form can be expressed in decimals if you have denominator, that is fraction, in the denominator should have only 2 to the power something and 5 to the power that thing. So altogether we make 10 to the power something, and 10 to the power something means this becomes 100, 1000, whatever. Place the decimal value and write the answer. What is the condition? This is our question number 7. Okay. What is the condition for a rational fraction being terminating? A fraction, answer I am writing for number 7. A fraction p by q, which is rational, is terminating if q has prime factors of 2 to the power m into 5 to the power n only. If your q has prime factors of 2 and 5 only, then only it is terminating, unless the fraction is non-terminating. One example, think of say 3 by, simple example, 3 by 7. Okay, this 7 is a prime number which is not 2 or 5. So this denominator do not have 2 or 5. So obviously this is non-terminating. Okay, there are various examples. If you have a number, say 5 by 300. So we can write this as 5 by 100 into 3. 100 into 3. 100 can be written as 2 to the power 2, 5 to the power 2. This is 2 to the power 2, 2 to the power 2 and 5 to the power 2. It has 2 and 5. But since because of this presence of 3, this becomes non-terminating. Why? It should have only the factors of 2 and 5. It cannot have others than 2 and 5 for a fraction to be terminating. Question number 8. Prove 6 plus root 2 is irrational. Okay, take a deep breath. Simple. Whenever you are being asked that 6 plus root 2 is irrational, don't take tension. Think, first of all, see how many marks is given to you. If this question falls for 2 marks, okay, what you do is rational plus irrational is always irrational. Directly you can give the answer. If it comes for 4 marks, then as we have done in question number 6, as done in question 6, root 2 is irrational. So we know that root 2 is irrational. So you have to write all that answer if it comes to 4 marks. First you prove root 2 is irrational. So we can even say 6 is rational. In the answer, 6 is rational, root 2 is irrational, rational plus irrational. It is irrational. Therefore, 6 plus root 2 is irrational. Fine, in the series we have proved that rational plus irrational is irrational. So rational is what? 6, irrational is root 2, 6 plus root 2 is irrational. Some of you, you'll find it difficult to write the answer this way. I have one more method of solving it. What we can do is, we can write in one more method. Let 6 plus root 2 be rational. So 6 plus root 2 equals to P by Q, where P and Q are primes. P and Q are primes. So we can write 6 minus P by Q, or we can even write P by Q minus 6, this will go that side, root 2 equals to P by Q minus 6. Okay. So this is a integer minus, say this is a rational, any rational number P by Q minus integer. Rational minus integer is a rational number. Q denotes rational. Fraction is always rational. This is integer. Rational minus integer is rational, and root 2 is irrational. Not possible. Not possible means what? Our assumption is wrong. This assumption is, our assumption is wrong. Therefore, 6 plus root 2 is irrational. Fine. So you may solve this question in 2 different ways. Fine. Let's move on to question number 9. Question number 9. Insert insert 2 irrationals between 2 by 5 and 3 by 5. Okay, so these are very simple questions. Still you should be knowing how to insert irrationals between any 2 rationals. 2 by 5 and 3 by 5. 2 by 5, which is equals to, if I convert it into fractions, multiply 2 by 5 into 2 by 2, it is 4 by 10, which is 0.4. 3 by 5 equals to 3 by 5 into 2 by 2. Why we are doing this? Because make denominator 10, so it is 6 by 10, which is 0.6. The irrationals are 0.4 and 0.6. In between these two there are infinite irrationals. I need to write 1, 2, what is been asked? Only 2. So you can write many irrationals. How do you write? Just write 0.4 and 0.6. Let us write 0.45. It is between 4 and 6. Then write 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0 and dot dot dot. So different numbers are coming. You can even write 0.5, 1, 2, 4, 6, 3, 1, 7, 8, dot 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 dot, your mobile number and so on. These are non-recurring and non-terminating. When you have non-recurring and non-terminating, it is an irrational number. So this is what we are going to explain. Question number 9. Express. Question number 10. Express root 11, root 15, okay, in nearest decimal form. That means approximate value of root 11, root 15, root 19, root 17. If you want to find, how will you proceed? You have a formula for this, okay? Root over, this is formula. Formula is root over x plus or minus y. It is root x plus or minus y by 2 root x. Do follow this, okay students? Please follow this particular step to find the answers of around all the irrational numbers if you want to find the decimal form. Same, I have 11, root 11. Just choose a number which is a perfect square near to 11. So 9 plus 2 is 11. So let us write 9 plus 2. I am not using plus minus because 9 plus 2, 16 minus 5. So I have taken 9 plus 2. So x is your 9, y is your 2. So root x means root 9 plus, in fact it is plus, y is your 2 divided by 2 into root x, root 9. Fine. So the answer comes as root 9 is 3 plus 2 by 2 into 3, 6. If we cancel this also, 1 by 3. So 3 plus 1 by 3 is 0.3 bar. So answer is 3.3 bar. Actually it is not 3.3 bar, it is 3.125. So you can even write 3.33. Okay. So 3.3245, whatever number comes if you use calculator. But suddenly if you have to use the value of 11, root 11, you can write 3.32 or 3.34. That is the value of root 11. Let us try root 15 also in the similar way. Root 15. 16 minus 1. Fine. So I am using minus this here, this side. This is root 16 using the formula plus, minus it has. So minus 1 by 2 root 16. This comes as 4 minus 1 by 8. 1 by 8 is something about 0.125. So it is 4 minus 0.125. 3.874 or 5 or dot dot dot, whatever comes, that is the answer. So if you want to know root 15, it is 3.87 dot 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 dot, whatever. Root 11, 3.3215, whatever, that is the answer. But nearest form is 3.33 and its nearest form is 3.874. Okay. Students, this is your first chapter and I have already started class 10's chapter 1. You will not only understand the full chapter, but you have completed the most important 10 questions of real numbers. Hope to see you soon in my next video. Do comment if you want to have any discussion on the topics which I have discussed in my video. Thank you. Until then, bye bye. Take care.